Okay. So see here. See question number 16. Here question 16. A car starts from rest and moves along the x-axis with constant acceleration of 5 meter per second square for 8 seconds. A car starts from rest and moves along the x-axis with constant acceleration 5 meter per second square for 8 seconds. If then if it then continues with constant velocity, what distance will the car cover in 12 seconds since it started?
So can we use
So,
the third equation?
yeah,
Can we use the third equation for this?
you can use the you see the journey is divided into two parts. In the beginning, it starts with rest, initial velocity 0, and it has an acceleration of 5 meter per second square for a time of 8 seconds. So this is up to a time of 8 seconds. Up to a time of 8 seconds, it achieves a certain distance. So here we get the time to be 8 seconds, and it has traveled a certain displacement x1. Let's say it has the displacement made in the x direction. So let this displacement be the x1 displacement. Now after this, it stops acceleration. After 8 seconds, there is no acceleration. Okay. So whatever velocity is attained by this during this journey, so it continues to move with that velocity v for the next 4 seconds. So which completes its a total of 12 seconds. It's like this. Okay, so first 8 seconds with an acceleration and the next 4 seconds without acceleration. Okay, so I want you to first complete your calculations for the first 8 seconds. For the first 8 seconds, find the value of distance, find the value of final velocity just for first 8 seconds.
So we can use the second equation of motion in this one, right?
Yes.
Sir, will the final velocity be 40 meters per second and distance be 16 meters?
Sir, I'm getting the distance as a 160 meter.
Okay, so different people are getting different answers. So someone has
Sir,
to be
the
incorrect.
distance will be 160 meters.
Yeah, you are also getting distance as 160.
Yes, sir, 160.
Okay, so both of you are getting the distance as 160. Maybe you are correct. Let's verify.
Sir, even I'm getting 160.
Okay, so then you are becoming more and more correct then. Okay, find the final velocity.
The final velocity is 40, according to me.
Okay, so we get here final velocity. See, we can use v equals u plus 80. So we will get,
40.
yes,
Final velocity is 40. 40.
5 multiply 8, which is 40 meter per second. So how many have got 40 meter per second?
Sir, I got.
Yeah. So keep your cameras on. Okay, Harshit also got, I think. Okay. The next one, we find out the displacement S equals ut plus 1 by 2 at square. So u is 0, you get 0 plus 1 by 2 multiply acceleration, which is 5, and multiply t squared. So t is 8. You put 8 square, that's 64. You can cancel. You have 32 multiply 5. So you get 160 meters. So we got here x1 as 160 meter, and we got final velocity here as 40 meter per second. Now can you get the distance that it will travel in the next 4 seconds? So for the next 4 seconds, there is no acceleration.
Sir, can we keep the acceleration as 0?
Yeah, since there is no acceleration, so we will take here acceleration as 0.
Sir, the initial and final velocity is 40, right? 40 meter per second.
Yeah,
Sir, the
Sir,
final
is the initial velocity 40 meter per second?
yeah, for the remaining journey, now the velocity is 40 meter per second. It has reached the velocity of 40 meter per second. Okay. So tell the distance.
Sir, 32 meter.
Oh, I think you should be getting 160 meter. Check it. Use the formula S equal UT plus 1 by 2 AT squared.
Sir, A is 0. So 1 by 2 into 0, which will be 0. UT we have to do first.
U is not 0. Now this for this part, it is moving with the initial velocity of 40 meter per second.
So,
So now it
Sir,
has
the
the
distance number
initial velocity 40.
sir,
Yes.
320
would be also 160 meters only.
Yeah. So now it's also 160. 1 by 2 multiply 0 and then t square. So still you are getting 160 meter. So what is the total distance traveled?
Sir,
20 meter.
320 meters. So now this question was a little bit different from the previous questions.
yes, sir.
Yes. So you have to see what formula to be used. You also have to use your logic that it has attained a velocity of 40 meter per second. Continue to move with a velocity of 40 meter per second. Okay. So this should be the initial velocity for the remaining part of the journey. Okay. Now let's see the next question here. So this one is a very simple one. Question number 17. Question number 17 is simple pretty. Let's see. A motorcyclist drives from A to B with uniform speed of 30 km per hour and return back with a speed of 20 km per hour. Find its average speed. Okay. So it's moving from A to B with a speed of 30 km per hour and return back with a speed of 20 km per hour. You have to find the average speed. We had done one such question in the beginning when we were doing about the average speed. Okay. So if Navya, Harshit, Yukta, all of you turn on your cameras, Pranav.
Sir, my camera is on.
Pranav's camera is on.
Sir, this is Harshit. Isn't my camera on?
Okay. So Navya, are you getting?
Yes, sir.
Okay. So for this question, see there is nothing distance as given. We just need to utilize the formula of average velocity. So let us say the student or motorcyclist starts from this point. It travels to a certain point and then return back. So suppose the distance between these 2 points be x. We do not know the distance, and the distance is not given here in the question. Okay. So let the distance between the points A and B be equal to x. Let this distance be equal to x. Okay. So the distance here is x, and from A to B, when it is going from A to B, it is traveling with a speed of 30 km per hour. So A to B, the speed is 30 km per hour. And from B to A, the speed is 20 km per hour. We have to find average speed, and the formula of average speed is given as total distance by total time. So is there anyone who can tell how to solve? Yes. How to solve the questions?
So can we keep the time as 1 hour?
Yeah.
Can we take the time for example 1 hour?
No. How can we
So,
take that?
sir, we can first find the total distance and then the total time. And for finding the total distance, we can take x upon 20 plus x upon 30. And then finding the total time, and then we can divide them.
Yeah, you are correct. Navya, you can go. You can go solve it out. Okay. And okay, see. So we can find out the time that it will take from A to B. Let that time be T1. So let there be some time T1 to go from A to B. So this time T1 would be equal to x by 30. Then you have time T2, which will be equal to x by 20. That is the time for returning back. Right? Distance by speed, that is the time. So time while going, time while coming, you can find the total time. The total time would be equal to x by 30 plus x by 20. Okay. So you can take the LCM, solve it. You will get 2x plus 3.
5x by 60.
Yeah, 5x by 60, which is equal to x by 12. So total time is x by 12. And what is the total distance?
X.
No, not x. It is 2x.
Oh yeah.
Yeah. So total distance is 2x. We can write here 2x divided by total time, which is x by 12. So x by 12. And hence you will get 2x multiplied 12 by x. Anyone got the answer?
20.
24 kilometers per hour.
Yeah, we have got 24 km per hour as the average speed. So average speed is 24 km per hour for this journey. Let's see one more question. See question number 21. We'll be doing question 21 and 22. You have an object starting from rest, travels 20 meter in first 2 seconds and 160 meter in next 4 seconds. What will be the velocity after 7 seconds from the start?
Or we should take total displacement by total time.
Yes, what we shall take?
The total displacement will take by total time, sir.
Yes, to speaker वाला. Speaker. So yes, what will be the answer? Try to solve this.
So I have doubt.
Yes, what is your doubt?
So the question is asking the velocity after 7 seconds, but in the given information, they only told about the first 6 seconds.
Okay, so that is what you have to find the other variables. You have to find the acceleration. You have to find the final velocity. You have to find the other variables like. So in the first 20 meters, see, in the first 2 seconds, you have been given time as 2 seconds, initial velocity u as 0 meter per second, and displacement is equal to 20 meter. Okay, so we will find the acceleration here. Acceleration is what we need to find. So can we use the second equation of motion?
Yes, yes, sir.
So can
Yes,
we
so
do meter per second square?
So
yes,
is the answer 3 seconds?
3
Oh, 3
seconds
meters
for
per second. 3 meters per second.
we have to find acceleration.
Oh, yes, sir.
Okay, so let's see first. What is the acceleration we obtain? S is given as 20 equals 0 multiply 2 plus 1 by 2 multiply acceleration. And here acceleration we do not know. Time is given as 2. So put t squared. You get 20 equals 0 plus. Now I think how many of you have cancelled this 2 with this 2?
So we have to write 4 in the place of 2 whole square. So we get the answer as 2.
Yeah?
So we will get plus a 2a plus 2a.
Okay, we'll get here 2a.
Sir,
And hence acceleration will be 10 meter per second.
yes, sir. 10 meter per second.
So can we use the formula for acceleration meter per second? Sir,
Yes, sir. Okay. So have you got the acceleration as 10 meter per second square?
Yes, sir.
Yeah. So now you have to, the acceleration, time. Can you
Sir,
find out?
final velocity for first 2 seconds, no, sir.
No, final velocity for 7 seconds, after 7 seconds.
Okay, sir.
Okay. So we'll be using V equal U plus ET. It should be equal to U, which is 0 plus acceleration is 10 multiplied T, which
sir,
is 7.
sir,
Yeah,
70.
yeah, it's 70 meter per second. Okay. So we didn't even had to utilize the second part here. That's given.
Okay, sir.
So see some more questions, and then this is the last class. If you are having any doubt in any question, you can ask. Even if you have your questions, you can put up. Okay, let's see this question number 22. It's about an electron. Okay. So you have an electron moving with a velocity of 5 multiplied 10 to the power 4 meter per second, enters a uniform electric field and acquires a uniform acceleration of 10 to the of 10 to the power 4 meter per second square in the direction of its initial motion. Calculate the time in which the electron would acquire a velocity double of its initial velocity. So initially it seems to you it's given 5 into 104. This is not 5 times 104. This is 5 times 10 to the power 4. So you are given initial velocity as 5 times 10 to the power 4 meter per second. And you are given acceleration as 10 to the power 4 meter per second square. Okay. And you have to find the time for which its velocity will double. Okay. So I'm waiting for you to solve this question. Especially to solve this question, let's see who is able to solve it out. I'm giving it 2 minutes to solve this question.
Sir, will the time be 5 seconds?
Okay, let's see. What should be the final velocity?
Sir, 2 times initial velocity.
Okay, so we'll write it as 10 multiplied 10 to the power 4
Yes, sir.
meter per second, right? Then we need to find time. So you can either use first equation of motion or you can use the formula of acceleration. So if you use the first equation of motion, we'll get V equals U plus AT. So V is 10 multiplied 10 to the power 4 equal U, which is 5 multiplied 10 to the power 4 plus acceleration, which is 10 multiplied 10 to the power 4 multiplied t. You can take out 10 to the power 4 common for from either side, or you can even subtract this. So there are various ways. Either you take out 10 to the power 4 common here. You will get here 5 plus t. And here you have 10 multiplied 10 to the power 4. So 10 to the power 4 and 10 to the power 4. अरे रोज मोटे मैं जानी मैडम लगे बड़ा माल पाखुं गाड़ी कहाँ गाड़ी उदाहरण तरह ठीक है पहले के समय ठीक है इंतजार करने 10 और भी इंतजार के लिए क्वेश्चन के लिए पाखुं उदाहरण करवाना ठीक है Okay, so let's see. So you have the formula, you have 10 equals 5 plus t. So you got here acceleration. I think I was disconnected, right? I was disconnected for a moment. Let me share the screen again. Okay, see. So here you have how much distance the electron would cover in this time. So in this time, what would be the distance traveled by the electron? So which equation of motion we will utilize now?
The second one.
Yeah, use the second equation and obtain the value of displacement.
Yes, sir.
Yes. Okay. Anyone got the answer for the displacement? How much will be the displacement of the electron? Yes, Rohit, have you got the answer for displacement?
So I got 5.
You got just 5 meter. Okay.
Yes, sir.
See, did you use this S equal ut plus 1 by 2 at squared?
Sir,
Yes.
sir, I got 375,000 meters.
Okay. Yeah, that's right. So let's say this is your u multiply time. So your time is given as to you as 10 okay, time we got here 5 seconds. So you'll put time as 5 plus 1 by 2 multiply acceleration, and acceleration is applied power. Sorry, acceleration is just 10 to the power 4. Here is 10 to the power 4 multiply t squared, which is 5 squared.
Sir, I got the answer as the 3,75,000.
Hmm. What did you get the answer as?
3,75,000.
Okay. So you'll be getting here 10 to the power 4 and 25 plus 12.5 and 25 plus 12.5 means this is your 10 to the power 4. You get here 37.5. So you get 37.5. That's your answer. And I can write it in simple way as 375 kilometer. So
Yes,
have you
sir.
understood how can we write? Yes.
Also, can we write it as 3,75,000 meter?
Yeah, that is also correct. Or you can just keep it as 10 to the power 4. Okay. We can write it as 37.5 multiply 10 multiply 10 to the power 3. And we know 10 to the power 3 meter is kilometer. So we can write this as kilometer. Multiply it with 10, you will get 375. So you get 375 kilometers or 3,75,000 meters. Both are correct. Okay. So I don't think you people have any doubts from this question. So this
No, sir.
question number 25 is your homework.
Assignment.
You can, this will be added in the assignment also, or you can take a screenshot of this question right now. I'm adding it in the PDF. You can take it direct screenshot and attempt this question as a homework. So here is the question.
Yes, sir.
Okay. Okay. So bye all of
Okay.
you.
Bye, sir.
Bye. See you.
Sir, I have a doubt.
Yes.
Sir, there are two types. We will be learning about two types of graphs, right?
Yes.
Okay, sir. Sir, will there be numericals related to the graphs as well?
Yes. There will be.
Okay, sir.
Okay.
Thank you, sir. Bye, sir.
Bye. Bye.